Uh, Good day, everybody. My name is Anne Kettunen, and I am a scientist at Nofima in Department of Breeding and Genetics. And today I'm presenting the results from FutureEUAqua Work Package 1 on sustainable breeding of important European aquaculture species in this MAIA webinar. On this slide, you can see all the collaborators. We had many industrial partners in this project. And today I'm only concentrating on the results regarding climate resilience of 3 aquaculture species in European aquaculture. But first, I will present what our work package in general was about. Our main goal was to assess, validate, and demonstrate the level of the ability of the current breeding programs, their breeding goals and methodologies in 4 of the main European aquaculture species to answer the following future challenges. First of all, namely, increased need for utilization of alternative feed sources in aquaculture feeds. And number 2 is this, what I'm presenting today is the need for resilience in the face of climate change. And the third, that we looked more broadly and maintained and increased animal welfare through robustness and disease resistance by validating the current selection methods in both in the current environmental conditions and also in the future. And here I have also listed our collaborators. So today I'm talking about the resilience studies that we conducted in VP1 in FutureEUAqua. First of all, why we were motivated to do this is because climate change brings upon several climatic elements. For example, rises in sea temperatures and sea levels, ocean acidification, increased of risk of diseases, parasites, and harmful algal blooms. Also changes in rainfall patterns and sea surface salinity, and climate secondary sort of effect on is also this uncertainty of external input supplies, for example, feed ingredients and their availability. And it also increases the frequency of severe climatic events, storms, extreme temperature fluctuations, and so forth. In aquaculture, this has a great effect because many of the fish species are poikilothermic, and rising temperature may affect production traits directly, and cause thermal stress and make the fish more susceptible to different diseases, and also increase the risk for more opportunistic disease outbreaks. So we had many motivations to investigate the climate resilience of current breeding program genetic material. First of all, I would like to say a few words about what I'm going to present is the genotype by environment interactions. This is a simplified example what we geneticists are interested in when we talk about production in genotypes and their level of production in different environments. On the left-hand side, you can see a situation where we have tested 3 families in 2 diets, where the family B has increased its performance between the diets. Family A has kept constant production, but family C has been performing worse in diet 2 than what diet 1. But if you notice that this is only affecting the level of production, what we call scaling effect, but it doesn't affect the ranking of the different genotypes, families across the environments. On the right-hand side, you see the re-ranking, which is the main interest of breeding programs, commercial breeding programs, when they deliver material to different types of environments. In this case, the diet, you can see that again, the family A is keeping its level of production, whereas family B is excelling in diet 2 and actually has the highest production in body weight, and family C is the most inferior. So studying of G by E will provide valuable information on how aquaculture breeding can prepare upfront to future challenges. This affects how the genetic gain obtained in the breeding nucleus will be realized by practical aquaculturists in their own production environments. It also has a great effect for the breeding programs, how they choose to strategically run their breeding programs. I will come back to that in the conclusions in this presentation. So in short, we investigated 3 different species in genotype by climate, namely Atlantic salmon, European sea bass, and European gilted sea bream. I'm not going to explain all the details, but you see here that the main point is that salmon was tested in 2 geographical locations with identical family material, siblings from the same full zip families. Approximately 3,200 individuals were registered. For sea bream and sea bass, we used laboratory conditions where fish were tested under volatile and smooth temperature regimes, mimicking some real temperature regimes in the Mediterranean area. The whole sort of a temperature sum was the same, but the difference between the treatments was the fluctuation in a rapid or smooth manner. We had almost 7,000 individuals registered from these full zip families. All fish were also individually tagged, so we could repeatedly measure some of the fish. So just quickly, the results of these 3 species. In South and North, where we used also 2 diets, but this is not the topic of this presentation, we had a little bit different grow-out period in length due to some environmental challenges. But what we found out that in both environments, we observed moderate to high heritability to growth, giving a great opportunity for growth selection in both environmental conditions. But what is most important from the point of the genotype by environment interactions are the cells that are not on bold, the end weight and thermal growth coefficient genetic correlations that were above 90%, meaning that there is no significant genotype by environment interactions. This means that the families that are ranking highest are the best in environment north, are also ranking highest and best environment south. We also conducted a QTL study, but to look for significant genetic association between the growth traits. We didn't find any QTLs, but our investigation supported a polygenic inheritance that the same genetic markers operate on favorably on growth in both environments. We look at the similar, these volatile and smooth temperature regimes for sea bass and sea bream, and this was done in a limited 4-month trial in sea bass. And we noticed that there was no growth differences in none of the body weights that were measured during the growth period in the sea bass. The tagging weight, the weight 1 and the weight 2, both volatile and smooth regimes produced equal growth. We did the same experiment 1 year and later for sea bream in the same facilities, and for practical reasons this was only 3-month trial. And similarly, we did not notice any difference between the growth in the volatile or smooth environments. We estimated also genetic parameters where we observed moderate heritability for body weight in volatile and smooth, both in sea bass and sea bream. And again, the cells off diagonal 0.99 and 1 indicate that these are genetically the same traits, meaning that there is no significant re-ranking of the genotypes across these environments. So our main conclusions are that the high genetic correlations between growth traits across climates and temperature regimes in these 3 species indicate non-significant genotype by environment interactions. So independent from the environment, growth can be genetically improved by selective breeding in these 3 species. And the relevance for implementation for the industry are the most important here. We say that these results indicate the growth selection in breeding nucleus in the current environment conditions will also be effective in the changing environment. And this also means that breeding companies can successfully serve large markets using genetic material from a single breeding program, and that the fish farmers are guaranteed to experience that the expected genetic gain from the nucleus will realize also in their production environment. And overall resilience regarding climate change and novel feeds is expected to help the resource optimization and to promote predictable and sustainable aquaculture production and increased animal welfare in the important European aquaculture species. There's only a couple of reservations for the relevance is that we studied only one breeding population per species, and breeding populations have differences in their genetic background and management of inbreeding, for example. So these results may not be global for all the populations of bass, bream, and salmon, but this will encourage the breeding companies to do similar investigations in their own breeding material. So this was the results from climate resilience study in the FutureEUAqua VP1 in very short. And with this, I would thank you for your attention.
Good afternoon. My name is Rebecca Pogni. I acted as a coordinator of the FISH4FISH project, and I am delighted to present the main results of the project. The project was granted under the European Maritime Fisheries and Aquaculture Fund under the Blue Lab topics. So the project works at the interface between research and industrial exploitation, and it represents Europe's circular and blue economy. It's an example of these aspects. So the project is an Italy-Spain collaboration. The partnership is composed by 2 universities, 2 research centers, 1 business association, and 1 enterprise. And the goal, the aim of the project was to produce an active packaging material starting from fish wastes. So the scenario is represented by the plastic pollution, but we know that fossil-based plastics were introduced in the 60s on the market due to the discovery of Giulio Natta and Carl Ziegler, who won the Nobel Prize for the discovery on high polymers. But from that time, paired with the beneficial effects on the use of this material, we have an increase, a tremendous increase in plastic pollution. And the packaging, particularly food packaging, represents one of the largest application field of this material. So the main problem with this material is their end of life. Because it cannot be degraded in the environment, but we have the production of nano and microplastics which have damaging effect on wildlife and also on humans' health through the food chain. So nowadays we need to replace these plastics, conventional plastics, with the so-called bioplastic. So in this scheme you can see that we can hold bioplastics, different materials, and the research is mainly focused on those materials based not only bio-based but will be biodegradable. So as an example, I would like to to cite the polylactic acid, because polylactic acid has a big market and is present on the market as a bioplastic. But as you can see, this material is biodegradable only in industrial composting plant, and while if it is released in the environment or in the ocean, it cannot be degraded. So the problem is a complex problem, and we in FISH4FISH project we have tried to obtain an active packaging material to reduce microbial spoilage in order to enhance the fish shelf life, but at the same time the material is home compostable, so it is biodegradable and can be used as a fertilizer and microbial preservative for plants. The material, the main components of the material is represented by chitosan obtained from fish waste, is represented by the exoskeleton of crustaceans. This material is composed by different components like calcium carbonate. Calcium carbonate can be an important component in the pharmaceutical field, proteins which can be used for animal feedings, and a pigment named astaxanthin with high antioxidant properties. But at the same time, chitin is a biopolymer rich in nitrogen, is not soluble, but its soluble form is represented by chitosan, which is obtained by the acetylation of chitin. Chitosan has many interesting properties and it is biodegradable and with antimicrobial activity. And chitosan can be found with different molecular weight and acetylation degree, and the so-called chito-oligosaccharides represents the low molecular weight chitosan, and these components have a higher antimicrobial properties. So our project starts from these materials, and I would like to show you this short video highlighting the project itself.
Have you ever thrown away a pre-packed fresh fish because of its short shelf life? There's a lot of fish food being wasted every day. At the same time, it produces lots of plastic packaging waste. This not only contributes to the plastic litter problem and climate change, but also its unsustainable and non-conservative use of marine resources itself. What if we can use the wasted fish food to tackle the above problems? The FISH4FISH project aims to produce innovative, active, and sustainable packaging material based on chinitolytic derivatives using marine biomass wastes and lignin nanoparticles functionalized with chito-oligosaccharides, which confer antioxidant, antimicrobial, UV shielding, and improved mechanical properties. Applying such packaging not only helps to avoid the use of plastics, it also helps to tackle microbial spoilage to enhance fish shelf life. And once a package is wasted, it is biodegradable and compostable, and it is active as fertilizer and microbial preservatives for plants. This will also turn the fish processing industry into an environmentally friendly bio-based model of circular economy and blue economy. Plus, it will bring a bunch of economic advantages too.
So as you can see, this in this slide, the project is reported, but I would like to add also that we have performed a life cycle assessment study where we have analyzed the impact of this production not only on the environmental point of view, but also on its cost and its impact on society. And all of these aspects gave us nice results. So this, as I mentioned you before, we started from lab scale, where we have defined the composition of the biocomposite. Then we have moved to the production of prototypes in terms of trays and films to be used as lead with the trays, and the company, the partner, which was the partner of the project, move from lab to industrial production with to obtain the prototypes of this material. At the end, we have obtained through different processes, through the thermoforming and the film thermoforming to obtain the tray, and the film blowing for the production of film. And once we have obtained these prototypes, we have tested this packaging material in presence with fresh fish. Then, paired with the characterization of the material with the fresh fish, we have determined the migration of heavy metals and allergens. Then we have tested the ecotoxicity and the fertilizing properties of the material, and at the same time the disintegration and biodegradability of the components. And all of this study said us that the material was a good biodegradability and compostability. During the lifetime of the project, we have had contact with different stakeholders, like large companies, but also companies related to the fish and aquaculture field, and in general companies working in the field of food packaging and consumer goods. The project fulfills different aspects to the European legislation related to the reduction of plastic pollution from coast and seas. We give a new value to the fish industry waste and enhance competitiveness of fish processing industry, increasing the shelf life of the fish. At the same time, we have a reduction of food waste, and we can contribute also to soil health, because we are able to produce a compost of high quality. At the same time, we can implement also different sustainable development goals. So here are the contact and the more information where you can find our project. At the same time, I thank you for your attention.
Good morning. My name is Bernardo Basurco. I come from CIGEA, the International Center for Mediterranean Agronomic Studies. And I was the technical coordinator of the project MedAID, Mediterranean Aquaculture Integrated Development. Together with me, although you cannot see it in the camera, is Dolores Furones. Dolores Furones is a researcher from IRTA, a researcher on aquaculture, that was the scientific coordinator of MedAID. I'm going to try to summarize what was MedAID, and some of the main inputs or goals that we achieved. So first is that MedAID tried to answer a call that was launched in 2016, call that it was entitled Improving the Technical Performance of the Mediterranean Aquaculture. The project has a duration of 4 years and a half. It started in May 2017 and finishing in October 2020. So when MedAID started trying to answer to the call, the sector was, let's say, in a crisis. After the economic financial crisis that happened in the 2010s, the sector was stagnant, and there were many different reasons that were discussed, pointing out at the problem of this stagnation, whether the way financial, the performance of the sector, technically performance was also stagnant. Maybe the feed conversion index was not improving. There was diseases. Some companies were breaking down. Others, well, there were different things happening. And with this scenario, the project was approved, and then we tried to answer to the call what was proposing. So what we had to try with MedAID is our main objective was to try to increase the overall competitiveness and sustainability of the Mediterranean marine fish farming sectors through the whole value chain. So we did like a kind of integrative approach for the sector, not only the companies, also what is the whole sectors, other actors that are participating, like would be policymakers or companies, farmers, scientific people from academia were considered in our approach. And also it was considered that the sector, it happens in the whole Mediterranean and not only in Europe. And that was probably one of our main approaches. We started the project with a first diagnosis, what we call a holistic assessment, in order to clarify, try to gain light about what were the real reasons behind that stagnation of the sector that happened at the beginnings of the 2010s. In order to identify the main technical, environmental, economic, and social constraints that condition the sustainability of the sector. And after that, we focus on the development of innovative knowledge and tools to improve the performance of the production systems to create and foster added value products and business plans which are socially acceptable. To end with the provision of practical approaches and recommendations to help integration, harmonization, and governance of the sector across the Mediterranean Sea. So those were the objectives. And the way that we conceive our project is that we have three main blocks. One block that was dealing with technical issues in order to try to improve technical performance, and another block dealing with products and consumers, and a third block dealing with socioeconomic aspects. Under these three blocks, there were different subjects, like regarding technical. So we work on growth, performance, on nutrition, genetics and breeding, disease, health management and welfare. Under the products and consumer, the project tried to develop new products of other values, made a consumer assessment, and the socioeconomic aspects. We're working on the assessment of the business performance of the sector in order to propose business plans and marketing plans. And also we work on what is called the social acceptability of the sector, because this is one of the main constraints that the sector is facing. Has been criticized for the sector for not being very sustainable, and probably there is a social opposition, or there was a social opposition in some places, and that is very related with governance. So all these aspects were treated in MedAID project. So you have asked me to make a summary of what could be the solutions that the project came up in order to tackle these problems that I briefly summarize. So the project in all these disciplines that I have mentioned before, technical, well, performance, growth, nutrition, health diseases, genetics, product development, economics, and social issues, we try to provide tools, guidelines, protocols, recommendations, and also specific training in order to do a proper transfer of knowledge. And just to give you an example, because we don't have time enough to cover all the results that we have developed in the field of health management. So we're working in the development of a risk assessment tool for the evaluation of risk against relevant pathogens in order to propose biosecurity plans for the companies. or other things that we have done. We develop a diagnosis manual in order to improve the communication and harmonization of diagnosis competences in all different countries. Or we're working in the development of a new vaccine for one of the most important diseases that was affecting the sector, the norovirus, the VNN, that was affecting and is still affecting Sibrin and Sivas. That at the moment that the project was approved, there was not vaccines, but later on those vaccines were developed by some companies and came out to the market. And finally, in this field, we work, for example, in the establishment or definition of operational welfare indicators for Sibrin and Sivas, something that was not already defined at that moment. That is helping now the sector to ask to some bodies the certification for welfare. Another subject, for example, is the development of new products and market and consumer assessment. So MedAID worked on these issues in order to provide technical information needed to facilitate the development of new aquaculture products. So the project did a very deep analysis of consumer preferences about different products, different preparations, and different categories in order to see if there are niche markets that can accept or not better one product or another. So that was done by MedAID as a basis for developing new products based on different new technologies, food technologies. And regarding socioeconomics, the project has contributed to consolidate the economic performance and sustainability of the sector by assessing main bottlenecks in the production and trade. For example, we look at the price, trade and price, things like this, in order to propose new strategies. And the reason to do that is because the sector was criticized for many years to base their development on production development. And that it was not well oriented to the markets or to the citizens. So we try to provide more light about how the companies of the sector should focus, not base the performance and the development only on improvements in production or reductions of cost, but also to develop sustainable marketing plans. And in socioeconomic, we develop social acceptability guidelines. So that is something that was not deal or work before on the sector, to understand better how local communities see might be pro or reluctant to aquaculture. For that, there are social technologies or methods that can help you to work with local communities in order to valorize these issues and try to explain local communities what is aquaculture in order to improve the local and social stability of the sector. You have also asked me about living lab or case studies. So we don't have living labs, but we have something that might be similar. As in the Work Package 2, that it was growth and nutrition. We have a case study as a proof of concept and validation of feeding practices and strategies. In this research, 2 fish farms from 2 different locations, from the Mediterranean Spain and from Eastern Mediterranean Greece, they were approved to implement a trial test, a field trial test, in order to work in similar conditions, but to compare the performance of that is happening in different environments. So that was the idea. And the results, in one way, they were not very conclusive, but they were for us very good, because one of the things that we saw is that it validated the research that previously was done before on laboratory, on aquarium or on laboratory. Field trials are not very frequent because they are costly and companies sometimes are not prepared for that. And well, that was a good case study. something that might be closer, what is a living lab for you, is that in the Work Package 7, dealing with governance and social acceptability issues, we did a novel analysis of institutional and social constraints that happen in the development of the sector. We tested protocols, methodologies, and tools for stakeholder engagement to support the emergence of social licenses associated to business models of aquaculture development at local scale. Those local studies happen in three countries, in Greece, Spain, and Tunisia, in different regions of these countries, where through social methodologies, there was discussions, conversation, exercises with the local communities in order to help them to understand better the sector, to see from local communities what things they like more or they like less, or what things need to be explained better. And we found that very, very interesting, because the sector, normally for the projects to be developed, the sector or the investors need to prepare a technical project, a financial project, but the social issues are not taken into account. One of our main proposals was that on this project, social issues will be considered. And that was one of the main recommendations that we have regarding this work. For anyone working to develop an aquaculture project, has to show the viability, technical and economical viability, but also has to study what is the local acceptability. Because when we have spoken about these issues regarding acceptability, or there has been more a high level, a high administrative level, and less a local level. Well, how citizens and stakeholders can apply lessons? Well, I have told you different examples, but something that I would like to share with you is the toolbox that we develop in MedAID. So we develop a toolbox where everything that was produced is accessible from there in a friendly way. There we have a series of conclusions and recommendations for all the work packages that the project is working on. You can access to the manuals, to all the reports, to deliverables. Those, for examples, just to give you an example of something that I haven't had time to say, is that on socioeconomic issues, there is a report, a work done about mass media coverage of aquaculture for the identification and context analysis of the news on aquaculture. And that is a way for the companies, for those working on aquaculture, to help them to improve communication strategies, to see how the media is analyzing, presenting the information of the sector. Well, I told you about the market validation, marketing plans, social acceptability. That all this information can be found there, as well as those issues that are more, let's say, research-oriented or technical-oriented, as health management, zootechnics, issues regarding growth, nutrition, genetics, and breeding. And that will be my summary of you have asked about MedAID.